In this video, we are going to talk about matter. We're going to talk about the types of matter, and we're also going to talk about the phases of matter. This video is split into 3 parts. The first part is, what is matter? What's the definition of it? What makes something matter? Then we're going to talk about how matter can be categorized. And last, we're going to talk about the 5 phases of matter. First, let's talk about what matter is. Matter is anything that has mass and volume. Mass is a measure of the amount of matter that's actually contained in something. So it's basically something's weight. Weight is slightly different than mass, especially when you get into physics, but in this class it's basically the same thing. The unit on mass is grams. And you can measure the mass of something on a scale. Volume is a measure of the amount of space that something occupies, and its unit is liters. You can actually measure the volume of something if it's a regular object that has, say, dimensions. You can actually measure the dimensions and calculate the volume. Or you can actually, if it's an irregular object, you can put it in water and measure its water displacement. So for something to be considered matter, it has to have both mass and volume. And you have to be able to prove it. The smallest unit of matter is an atom. The atom is made of smaller parts, but those smaller parts don't really exist on their own. They only exist within the atom. So the atom is considered the smallest unit of matter. We'll talk more about the atom later. All right, let's talk about the second topic. How can matter be categorized? There are actually 2 main categories to matter. The first category are pure substances. And the second category are mixtures. Let's talk about pure substances first. A pure substance is a substance whose composition doesn't vary. And what I mean by that is that if I have a sample of that substance and I split it into 2 parts, each part will contain exactly the same stuff. It won't vary at all because it's got a pretty consistent composition all throughout. If you were to look at the composition of a pure substance at a molecular level, you would notice something really interesting. You would notice that there is only one either type of element in that compound, so that's why it doesn't vary in composition, or one kind of molecule, like here or here, throughout the whole thing. As opposed to something like this. This is a mixture. And what I mean by that is that if you look at if I divide this in half, I don't have exactly equal amounts of both things on either side. So it varies in composition depending on how I, split up the sample. So pure substances are made of only one type of element or compound. So what's an element and what's a compound? Well, since pure substances can be further divided into these 2 things, we might as well talk about them. So let's focus on what an element is first. An element is a substance that's made of only one type of atom. And there's lots of different kinds of atoms. You have, for example, oxygen atoms, carbon, hydrogen, or neon. These atoms are found, you can find a list of atoms on your periodic table. And you'll notice atoms have both a name and a symbol. So here's the periodic table. So there are 118 elements. Not all of them are naturally occurring. We'll actually talk a little bit about that in class. But this is a comprehensive list of all the known elements in the universe. Okay, let's go back now and talk about what a compound is. So a chemical compound is a pure substance that's made of two or more types of atoms that are chemically bonded to each other. So they're actually stuck to each other chemically, so it'd be pretty hard to separate them. For example, you have water, H2O, and you have like NH3 is ammonia. It's made of a nitrogen and 3 hydrogens that are all stuck together. Carbon dioxide is a carbon with 2 oxygens stuck to it. So there's the carbon in the middle and the 2 oxygens stuck to it. And then, of course, H2O2 hydrogen peroxide, H2O2, has 2 oxygens with 2 hydrogens stuck to it. So if I have a container of water, what I have is just a whole bunch of these all together in a container, floating around with each other. So that's a chemical compound. They're pure substances because if you isolate each molecule, they're all going to be exactly the same. So I should mention the law of constant composition. Let me move the periodic table here. Okay, the law of constant composition says that a chemical compound will always contain the same number and types of atoms no matter what the source is. So that's just a fancy way of saying that if I have water, H2O, and I get that from, say, I don't know, Canada, so I take that from a lake in Canada, and then I go get water from Mexico, it should still be H2O, right? It's not going to change just because I got it from two different sources. Water is water. It's always 2 hydrogens bonded to an oxygen. Okay. So we've talked about pure substances. Now let's talk about mixtures. A mixture is defined as 2 or more pure substances that are just mixed together in the same container. So if you were to look at these pictures that I have right here, this is a pure substance because it's all just that thing. This looks like it's an atom of some kind. And this is a pure substance because the only thing we have in this container are these molecules, which are just chemical compounds. This, however, right here is a mixture. That's a mixture because we have all 3 of these things hanging out or mixed together in the same container. They're not chemically bonded to each other. They're literally just mixed with each other. So some characteristics of mixtures. The big one is that they have a varied composition. If I were to take this mixture right here and I were to pour it into part of it into another container, I wouldn't get exactly the same amount of each of these different pieces in each of the containers. It would vary just depending on what ended up getting poured into the container. So picture something like trail mix. If I were to take a handful of this trail mix, just a big sampling, and I took another handful and I split them apart and counted the pieces, they wouldn't be exactly the same because it's a mixture. So let me move that up here. So there are 2 types of mixtures. So let's go through the 2 subdivisions of mixtures. First, you have heterogeneous or heterogeneous, if you want to say that, mixtures. Heterogeneous mixtures are where you can actually see the parts. So trail mix is a heterogeneous mixture. You can see all the parts. It's hetero means different, right? So you can see all the different parts. Another heterogeneous mixture, if you want another example, would be oil and water, where even though you mix it up, you can still see the oil and the water separate from each other, and they will separate if you let them. A homogeneous mixture is a mixture where you can't see the parts. What I mean by that, another word for a heterogeneous mixture, another way to say it, is that it's a solution. So I'm sure you've heard of solutions before, like salt water, sugar water. These are solutions. So if you were to look at a mixture of sugar water, so we have the sugar going into the water and then we mix it all around and we look at the sugar water, you can't see the individual sugar particles and the individual water molecules. It all looks very consistent, it all looks the same. That's a homogeneous mixture. Okay, so let's see. So we've talked about the two main categories, and now the last thing that we need to talk about are the 5 phases of matter. So let's do that right now. So you may or may not be aware that there are actually 5 phases of matter. On this picture I have 3 of the phases of matter. So we have solids. Characteristics of solids are this. Solids, the molecules vibrate in place in their crystalline structure. So if you were to look at this picture, you've got the molecules are sort of not bonded together, but they're held together with a force that makes it so they don't move around each other. So that's a solid. Okay. Let's make that a little smaller and we'll bring that over to here. So that's what solids are. Okay, let's talk about liquids. So liquids, this is a liquid. The molecules are not held together by a force, at least a strong enough force that makes them so they're stuck in a little pattern. So these are able to move around, so this guy and this guy can flow around each other. They don't have a formal structure like a crystalline structure because they're capable of moving. There's a definite volume going on, meaning that if you have 20 milliliters of water, you have 20 milliliters of water no matter what container you put it in. And then of course it takes the shape of the container that you put it in. So if I put it in a star-shaped container, it'll take the shape of the container. So gases. Gases are something that's very interesting. Gases really, they move very freely and very quickly within whatever container you put them in. And gases have a tendency to kind of ignore each other, meaning that this gas molecule and this gas molecule, they don't really stick together at all. They bump into each other and then just fly away from each other, unlike a liquid where they're kind of sticking to each other. They have no formal structure because they're just free. And of course, they take the volume and the shape of their container because they are so freely moving. So you can compress them into small containers or you can open up that container and they'll spread out. So that's a gas. Now, I'm not going to talk tons about plasmas, but plasmas are interesting because they're like a gas where they move really freely, but they're ionized. And what that means is that the electrons in the atoms have so much energy that they've actually left the building. They are no longer associated with the atom they came from. You find plasma, the biggest source or the most common place you'll find plasma is the sun. That's a plasma. It's not just hydrogen and helium gas. They're hydrogen and heliums whose electrons, so hydrogen has 1 electron and helium has 2, those electrons have actually they fly off, leaving behind hydrogen and helium, and those are ions, hydrogen with a +1 charge and helium with a +2 charge, and they're electrified and they're a gas, but they're ions in a gaseous state. You also find plasmas here on Earth in neon, like neon lights. So the gas inside of a neon light is actually neon gas that's been ionized. So it's electrons, it has 8 of them, have kind of just left the building and left behind neon with a charge. And there's one actual final state of matter that we've known about for quite some time called a BEC, which stands for Bose-Einstein Condensate. A Bose-Einstein condensate is less than a solid. And what I mean by that is it comes before solid in this range. And what I mean is that it's a solid that's been cooled to such low temperatures that the molecules almost stop moving. Or the atoms, rather, sorry. So the atoms are almost not moving at all. And that causes them to sort of cave in on each other and mash together into a superatom. So there's no longer individual atoms. They all kind of just merge together into one big atom. I'm not going to talk a lot about Bose-Einstein condensate, and I don't expect you to know it, although I may ask what the 5th state of matter is on a test for, say, an extra credit question. I should also mention that you can actually change phases of matter. So if you want to go from one phase to the next, you can either add heat. So if I'm at a solid and I want to go to a liquid, I would just heat it up. If I have a liquid and I want to go to a gas, I would heat it up, gas to plasma, heat it up. And then, of course, if I want to go the reverse direction from a plasma to a gas, I would cool it down, gas to liquid, cool it down, liquid to solid, cool it down, or remove heat. So here's a better diagram of what I just said. So again, solids to liquids. If you want to make a solid change to a liquid, you would add heat. If you want a liquid change to a gas, you would add heat, or energy, and gases to plasmas, you would add heat. And of course, to go in the reverse direction, you would remove heat. Remove heat. There you go. All right. So that ends our presentation on the 3 things I told you I'd talk about: what matter is, 2 main categories of matter, the categories of matter, and of course the 5 phases.